Hello and welcome to today's episode of Astronomy Answered Simply. Today's question is our solar system moving closer or further away from the center of our galaxy? So, I'd have to look at our current position in the galaxy as to whether we're currently moving closer or away from it. But at different times in our orbit around the center of the galaxy, we'll be moving closer to or farther away from the center of the galaxy. Our orbit is elliptical, and also it's going to be slightly irregular due to the fact that there's millions of other stars in the galaxy, well, hundreds of millions of other stars, and the gravitational influence at any given time will shift the positions of the stars in or out. Now, in a frictionless vacuum, which space sort of kind of is, without all the influence of all the other stars, you would stay in the same orbit pretty much eternally. You would never either fall into or get flung out of the galaxy. However, because there are hundreds of millions of gravitational objects, it is possible at some point we could move closer to the center of the galaxy or get farther away from the center of the galaxy, but we will never get pulled into the gravitational well of Sagittarius A star, the black hole at the center of the Milky Way galaxy, because unless something exerts a force on us to push us or pull us in that direction, our orbit would be stable otherwise. I mean, gravity is not it is a constant, but we also, in our orbit around the galaxy, just like our orbit around the sun, we have momentum. We have angular momentum. So we are constantly moving away, or we're trying to move in a straight line, but because of the gravity and the distortion of space-time, we end up going in a semicircular or elliptical orbit around the sun. Unless we encounter another gravitational influence that nudges us towards or away from the sun, we would orbit its mass in perpetuity. In the case of our orbit around the galaxy, at some point about 4 or 5 billion years from now, we're going to be merging with the Andromeda galaxy. So at that point, there's going to be lots of stars crossing each other and lots of interaction. But this happens on timescales of millions and billions of years. Effectively, for a couple 100 million years, or even the next billion or two, we're pretty much in a very relatively stable orbit. I mean, we're not going to be shifting more than a few light years in any direction towards or away from the center of the galaxy until such time as we merge with Andromeda, which is somewhere around 5 billion years from now. So we're pretty much, in an elliptical orbit. And yes, we move slightly above. I think we're above the ecliptic plane, depending on your perspective. But the other thing is, all motion's relative. So at some periods, we're moving out a little farther from the Milky Way center. At some periods, we're a little closer to the Milky Way center. But really, it's an orbit just like the planets. We will never get pulled in without massive confluence of stars crossing paths to pull us into the center of the galaxy. I mean, that's not how gravity works. There's a continuous force, but we also have the angular momentum that's keeping us from being pulled in, and we're not losing that because there's no friction. There's nothing causing drag and nothing slowing us down. So gravity in space works slightly different because On Earth, we're used to thinking of gravity as a pull towards the center of the Earth, but there's also friction due to air. When you think about space, there's no friction because there's hardly anything other than billions and billions of photons flying around. The giant amounts of mass, our planets have atmospheres that extend for hundreds or thousands of miles, but eventually it thins out to where it's pretty much nothing, non-existent. The molecules are very far apart, so that really doesn't have an effect. I mean, if we were to pluck out our sun and replace it with a black hole using some form of space magic voodoo, we would orbit the black hole in perpetuity. We would never get pulled in again unless an object or a gravitational influence shifted us towards it in enough momentum or decelerating our momentum relative to the black hole or to our sun to cause us to get moved and nudged in that direction. Newton's law of motion. An object in motion stays in motion unless acted upon by an outside force. It's a fairly simple concept, and it still applies to Einsteinian physics and general relativity. So gravity is not a push or pull, it's a warping or curvature of space-time. Once you understand that, gravity makes a lot more sense. The more mass an object has, the more space-time curves. Think of those giant bowls where you drop a penny in and it slowly spirals down, or a roulette table or a roulette wheel where you spin the ball and it spins and it slowly spirals and shrinks and shrinks and shrinks until it falls onto the wheel and then bounces around, and then you get your roulette number. That's kind of it. But if that roulette table had no friction, no air, no surface, and nothing to stop it, that ball would spin in perpetuity, forever. So that's the difference about thinking about gravity in space versus gravity in atmosphere or on a planet. It's the same. Gravity is the same, but everyone thinks about friction on Earth, and you forget that space is not entirely frictionless, but there's insufficient friction to decelerate us to the point that we would get moved or slowed to the point where we get absorbed by the central black hole without the influence of other gravitational objects nudging us in that direction or changing our trajectories. So, long story short, we're in a relatively stable orbit around the center of the galaxy until such time we are acted upon by an outside force. That's my answer to this question. I hope that helps explain it. At some point, I'm going to try and make a couple of videos, re-edit this video and add some graphics and add some, visual references to help people, because this is a very, gravity is an interesting topic, and I've done a lot of answers on gravity because it's misconceived or misunderstood by a lot of people, even engineers and physicists struggle with the concept of gravity. And when you stop thinking of it as a push or pull and you start thinking of it as a curvature of space-time, it makes a lot more sense. Go to your bed, drop a very heavy bowling ball or something like that onto your bed. Notice how it dips around the ball. That's the same way gravity acts. Imagine your object is going around it in, like that spiral on the roulette wheel or that spiral penny going down the well. So that's me trying to verbally explain all of this. So thank you, and like, subscribe, and ask more questions. Have a great day.